Hello folks, this is Cambridge Pre-University Certificate 2013 May-June paper 1, and the question number is 4, which is useful to the students of CAIA level as well. And this problem is very much a bit of tougher problem, which is the information I got from the examiner report as well. Many people committed mistake in this thing, so that's why I'm addressing this problem. It shows that the diagram shows a man standing in a lift, so person standing in a lift, so cable here, lift here. The forces acting on the man and the forces acting on the lift are as shown below. So T is the tension force in the lift cable, so cable here. N is the force from the lift floor on the person, so N should be from the lift floor to the person, W1 equal to weight of the person, T is the tension in the lift cable, W2 is the weight of the lift, D is the force from the man on the lift floor, so D is the force from the person on the lift floor. And we're asked which statement is correct. So one thing that we have to take care of in this problem is that it is not stated whether the lift is going up or it is going down. And in addition, it is not even stated that whether it is accelerating up or down, whether it is retarding up or down, or whether it is going with uniform velocity up or down. So that's why there are several cases possible here. So we have to go through each individual choices one by one. So here we are said N and W1 are always equal and opposite. It says that N and W1 are always equal and opposite. So that is not true. It's because when the lift has to accelerate upwards, this N force should be greater than W1, and when it accelerates downwards, at that time W1 will be more than N. So this is not true. Next is W1 plus W2 is always equal to tension force T. It says the weight of the lift and the weight of the person is always equal to T. That also again is not true. It's because if it is accelerating, T should be higher, definitely. If it is accelerating up, T should be higher than W1 plus W2. And if it is accelerating downwards, we will have W1 plus W2 is more than T. So it's also not possible. If N equal to W1, the lift must be at rest. Again, it's not true. It's because when forces are equal, resting is not only the condition, it can move with uniform velocity as well without thinking of anything else. And number D we have got if tension equal to D plus W2, the lift must have a constant velocity. So it says that if T equal to D plus W2, the lift must have constant velocity. So this makes some sense. It's because T is upward force, W2 and D is downward force. So at that time, this is W2 is the weight of the lift, and D1 is the force from the man on the lift floor, which means is the weight of the person. So weight of the person plus weight of the lift should be equal to tension force. If that happens, then the total force will be 0. Total force will be equal to 0. And if it is so, A will be equal to 0, which means V should be equal to constant. So choice number D is the correct choice. So total upward force and total downward force equal, which makes the total force 0, A 0, and then V constant. So D should be the correct choice.